So yesterday we talked about 7.4 part 1, which was just about rectangles. Today we're moving on to part 2, which also involves other quadrilaterals. We're going to have squares, we're going to have rhombuses, and then also we're going to still have rectangles and parallelograms and all that good stuff. And we're going to talk about how all of those things are related to one another. So with your 7.4 and 7.5 packet, go ahead and flip to the notes for 7.4 part 2, and we'll get started. All right. So it's only going to be one page of notes, and they are fill in the blank style for the most part. So you're welcome. Here we go. We're going to start with squares, which is hopefully, again, something you're familiar with a little bit from the rest of life and stuff like that. Let's talk about their special properties. So to start with, you may have heard the saying before, every square is a rectangle, but not every rectangle is a square. That is a true statement, and we're going to unpack that a little bit. Well, let's start with, every square is a rectangle, but not every rectangle is a square. Which means that squares basically have all of the properties of rectangles plus a few extra. So the extra properties that they have is that all four sides are congruent to each other. So as we can see in our picture here, we've got all four sides. They are the same length. We also have that the diagonals are perpendicular to each other, meaning that these diagonal lines where they cross, we get a 90-degree angle. And then we have the properties of rectangles. Some important ones that we may want to remember is that the corners are 90 degrees. Or the vertices, if we want to use the math word. The vertices are 90 degrees. So all four of these are 90-degree angles. All four angles, 90 degrees. All right, and then the diagonals also bisect, which was actually a property of parallelograms, and are congruent, which was another property of rectangles. So we can also say that the diagonals cut each other in half, but they're also the same length as each other. So all four of these lengths are the same. And then we can also say that the opposite sides are parallel, just like on parallelograms and on rectangles and stuff like that. So there's one set of properties. Another set of properties for the rhombus now. Every rhombus is a parallelogram. And has all the properties of parallelograms. Kind of like rectangles. But plus a few extra properties. So the extra properties. First one is that all four sides are congruent, just like on a square. So we know that all four sides are congruent to each other. You'll notice that a rhombus kind of looks like a squished square. It's like if you took a square and like shoved the corner that way, or like gave it a shove from the side, and then just tilted. Anyways, the diagonals are perpendicular to each other, also just like a square. So these are all 90-degree angles in the middle there. Another property is that the diagonals bisect the corners. So what that means is that this diagonal cuts this corner into two equal pieces, like that. And same with this one, it cuts the corner into two equal pieces. And since it's also a parallelogram, all four of these pieces are the same size. Same thing going the other direction. This gets cut into equal pieces as well. So we have four pieces that are all the same length, or not same length, same amount of degrees, same measure. Okay, Then, just like parallelograms, the diagonals bisect each other. And the opposite sides are parallel. So the diagonals bisect each other, but the thing that makes it not a square is that the diagonals are not congruent to each other. They're not the same length. So this part and this part are the same length here. This part and this part are the same length there, but they're not the same length as each other. One of these is clearly longer than the other one. This is the short one, right? Okay. But there's all kinds of different things that we can do and solve for with squares and rhombuses. So we're going to talk about a few of them. All right. The first one is we're going to find all the angles in a square. And the fun thing is that it's they're either 90 or they're 45. So here we go. We know that on a square, the diagonals meet up at 90 degrees. So if this is 90, that means that these are all 90 all the way around. We also know that the corners are 90 degrees. And we know that these are all the same length because the diagonals are equal in length and they bisect. So just like with our rectangles yesterday, we can get that this is an isosceles triangle. So if I go 180 minus 90, which was this angle, I get 90, which has to be split equally amongst these two angles. 90 divided by 2 is 45, which means that these are 45. And actually then these are 45 because this whole angle is 90. And these are all just the same isosceles triangle. So all of these corners that have been kind of cut in half like that are going to be 45s. So we've now found all the angles in that picture. Oh, I guess also what we should have also had up here is, we shouldn't assume, but in the problem, it would have told us also that ABCD is a square. And maybe it would have even had this label that all four sides are the same length. Okay. On the next one, we're going to look at a rhombus. It says the measure of angle DOC. So DOC is 2x minus 2. And we want to solve for x. So let's start with just that piece of information. The other thing that we know about a rhombus is that these angles are all 90. So 90, 90, 90, 90. 2x minus 2 equals 90. All right. So I'm going to add 2 to both sides. We get 2x equals 92. Divide 2 on both sides. We get a problem that we might get. And even though it doesn't say it in the picture right now, I'm going to suggest that we do this other problem as well. I'm going to say that this angle right here is 31 degrees. Could I find the other angles in this picture based on knowing that this is 31 degrees? And the answer is yes. All right. So first off, we know that the diagonals bisect the corners. So if this is 31, then this must also be 31. And this would be 31, and this would be 31. Everyone gets a 31. Well, except for these guys. These aren't 31. Then we could notice that this is a triangle where I know 2 of the angles. And we know the angles on a triangle add up to 180. So I could take 180 minus 90 minus 31 and get 59. So now I know that this is 59, and so is this, and so is that, and so is that one. Those would all be 59. You just have to pay extra close attention to which angle you're being asked for, because If they ask you, you know, what's the measure of angle ADC, they would want this whole thing. And together, angle ADC, 59 plus 59 is 118. So, you know, you just want to be careful that you're looking at the correct angle if you're asked for any particular one on a rhombus. Okay. But back to what we were actually asked in the question. They also have DC is 12 and AB is 3Y. So again, this is another thing that comes back to us directly from parallelograms. Opposite sides are congruent to each other. And then being a rhombus, all four sides are congruent to each other. So if this side is 12, I know that this side is 12, and this side is 12, and this side is also 12. So if they're all 12, then I can go 3y equals 12. Divide 3 on both sides and get that y is 4. All right. And these are just some of the kinds of problems that you can do with squares and rhombuses. There are so many different ones that, you know, and ways that they can ask these kinds of questions, but that's at least a good start for us for now. Okay, so that's it for the notes. Today's assignment is in IXL. So go ahead and once you close out of this, go back to the assignment, click on the IXL sections that are posted there, and do those to at least a SMART score of 80. Tomorrow we'll have a little bit more time to work on these and ask questions as well. So if you get hung up on one part or something, don't forget you can click Learn with an Example or watch a video, but also ask questions in class tomorrow and we'll get it all figured out. All right, have a great rest of your day. See you guys later.